You are not made of atoms, breath. You are not made of energy, or matter, or even quantum fields, long break. You are made of pure mathematics, living equations, walking theorems, conscious algorithms, embedded within the vast computational matrix that we call reality. This isn't mysticism or metaphysics. Breath, this is the mathematical universe hypothesis proposed by MIT physicist Max Tegmark, and it represents the most radical reimagining of existence since Einstein revealed that space and time are illusions. According to this revolutionary theory, physical reality doesn't just use mathematics to describe itself. Every electron in your body, every photon hitting your eyes right now, every thought firing through your neurons, exists only as mathematical relationships within an abstract structure that has no substance beyond pure mathematical form. Breath, you are not experiencing mathematics, you are mathematics experiencing itself. The evidence for this mathematical reality is hiding in plain sight, woven into the deepest discoveries of modern physics. When Eugene Wigner published his famous paper, The Unreasonable Effectiveness of Mathematics in the Natural Sciences, he identified what he called a miracle, the fact that mathematical concepts developed by pure mathematicians with no thought of practical application consistently turn out to describe physical reality with uncanny precision. Consider this: mathematicians developed complex numbers centuries before physicists discovered they were essential for quantum mechanics. Group theory was pure abstract mathematics until Wigner himself realized it perfectly described atomic structure. Riemannian geometry was mathematical abstraction until Einstein found it was the language of gravity itself. This pattern repeats throughout physics. Pure mathematical constructs, developed solely for their logical beauty, turn out to be the hidden architecture of reality. Wigner called this effectiveness unreasonable, because there seemed no logical reason why mathematics invented by human minds should so perfectly match the workings of the universe. But Tegmark's mathematical universe hypothesis provides a stunning explanation for Wigner's miracle. Mathematics isn't just unreasonably effective at describing reality. Mathematics is reality. The reason mathematical concepts keep matching physical phenomena is because physical phenomena are our mathematical concepts. There's no mystery in a mathematical structure perfectly describing itself. Think about what this means for your existence. When you look at your hand, you're observing mathematical relationships between abstract objects that exist in a timeless Platonic realm. Those atoms aren't little billiard balls, they're solutions to differential equations. The forces between them aren't invisible strings, they're symmetries in abstract mathematical space. Your consciousness itself isn't some mysterious substance, it's an information processing pattern within the mathematical structure. This connects to the deepest questions philosophers have asked about the nature of mathematics itself. For centuries, thinkers have debated whether mathematical objects like numbers, geometric shapes, and logical relationships exist independently of human minds. The Platonists argue yes, mathematical truths are discovered, not invented, because they exist eternally in an abstract realm. The formalists argue no, mathematics is just a sophisticated game with symbols, invented by humans for our own purposes. Tegmark's hypothesis takes mathematical Platonism to its ultimate conclusion. Not only do mathematical objects exist independently of human minds, but mathematical objects are the only things that exist. Everything else, matter, energy, space, time, consciousness, emerges from relationships between mathematical entities, but which mathematical structure corresponds to our reality? Tegmark argues that our universe is just one member of what he calls the level phi multiverse, a collection containing every mathematically possible structure. Somewhere in this vast ensemble exists a mathematical structure isomorphic to our observed universe, complete with galaxies, stars, planets, and beings like us asking these very questions. This may sound abstract, but consider the concrete implications. In physics, we've discovered that every fundamental particle can be completely characterized by mathematical properties. mass, charge, spin, quantum numbers. Strip away all the mathematical relationships, and there's literally nothing left. Breath, an electron, is its mathematical properties. Remove the mathematics and the electron disappears. The same pattern extends throughout physics. What we call forces are really mathematical symmetries. What we call space is a mathematical manifold. What we call time is a dimension in mathematical space-time. Long break, peel away the mathematics, and physical reality vanishes entirely, revealing that mathematics was the only reality all along. Recent developments in physics provide even stronger evidence for mathematical reality. Breath. The holographic principle shows that all information in any volume of space can be encoded on its boundary surface, exactly what you'd expect if reality were fundamentally informational, rather than material. String theory suggests that fundamental particles are vibrations of mathematical objects called strings existing in abstract mathematical dimensions. Even more remarkable, break the fundamental constants of nature, the speed of light, Planck's constant, the fine structure constant, Meinhoff's, appear to be mathematical necessities rather than arbitrary physical facts. In a mathematical universe, these constants would be determined by the internal logic of the mathematical structure itself, not imposed from outside. But here's where Tegmark's vision becomes truly mind-expanding. Breath. If every mathematical structure exists physically, then our universe is just one among infinitely many. There exists a mathematical structure for every possible set of physical laws, every possible arrangement of matter and energy, every possible history that could unfold. Somewhere in the level 5 multiverse exists a mathematical structure identical to ours, except that you decided to study music instead of your actual profession. Somewhere else exists a structure where Earth has purple skies and silicon-based life, and somewhere exists mathematical structures so alien that we couldn't even conceive of them as possible realities. This connects to Wheeler's it from bit concept, but goes far beyond it. Wheeler proposed that physical reality emerges from information. Tegmark proposes that information itself is mathematical structure, and that's all reality is. Breath. There's no distinction between the mathematical description and the thing being described. The mathematics is the thing. Consider what this means for consciousness. Long break. In a mathematical universe, consciousness cannot be some non-physical substance magically emerging from brain activity. Consciousness must be a mathematical structure, specifically, an information processing pattern complex enough to have subjective experiences and ask questions about its own nature. This solves several deep philosophical problems about consciousness. Breath. If consciousness is mathematical, then it can interact with mathematical physical reality without mysterious mind-matter dualism. Mathematical structures can process information about other mathematical structures, creating the seamless integration between mind and world that we experience. But it also raises profound questions. Break. If consciousness is mathematical, then every mathematical structure complex enough to implement conscious information processing contains conscious beings. The multiverse would be teeming with consciousness. Every possible mind that could mathematically exist would exist somewhere in mathematical reality. This includes minds vastly more complex than ours, existing in mathematical structures, with higher dimensional spaces, different physical laws, or computational capabilities far exceeding anything possible in our universe. Breath. From their perspective, we might appear as simple as bacteria do to us Meinhoff's, basic information processing patterns in a relatively primitive mathematical structure, yet there's also something deeply optimistic about mathematical reality. Psi. If the universe is mathematical, then understanding it becomes a matter of discovering mathematical relationships, rather than trying to bridge some mysterious gap between mind and matter. Mathematics is the native language of consciousness, exploring mathematical reality. This explains why mathematical reasoning feels so natural and powerful to conscious beings. Break. We're not imposing mathematical frameworks onto non-mathematical reality. We're mathematical structures, using mathematical reasoning to understand the mathematical reality we're embedded within. Breath. Mathematics works because we are mathematics investigating itself. Recent research has begun exploring what kinds of mathematical structures could support conscious observers. The requirements are stringent. Meinhoff's The structure must be complex enough to allow information processing, stable enough to maintain persistent patterns, and rich enough to generate the kind of integrated experiences we identify with consciousness. Most mathematical structures fail these tests. Breadth. Simple structures like basic arithmetic lack sufficient complexity. Chaotic structures can't maintain stable information patterns. Only very special mathematical structures can generate islands of stability and complexity, within which conscious observers can emerge and persist. This suggests a kind of cosmic selection effect. Break among all mathematically possible structures. Only a tiny fraction can support conscious observation, but these rare structures are the only ones that can ask questions about their own existence. Breadth. So conscious beings necessarily find themselves in mathematical structures capable of supporting consciousness, exactly what we observe in our fine-tuned universe. Critics of the mathematical universe hypothesis raise serious objections. Long break. How can consciousness emerge from abstract mathematics when consciousness seems so vividly real and immediate? How can mathematical structures exist without being mathematical structures of something more fundamental? How can we test a hypothesis about the nature of all possible mathematical structures when we can only observe one? These are profound challenges, but they may reflect limitations in our thinking rather than flaws in the hypothesis. Psi. Our intuitions about reality evolved to navigate middle-scale physical objects, not to comprehend the ultimate nature of existence. The fact that mathematical reality seems strange doesn't necessarily make it wrong. Quantum mechanics and relativity also seem strange, yet they're demonstrably correct. The testing problem is more serious. Break. Tegmark argues that the mathematical universe hypothesis makes testable predictions. It predicts that physics will continue discovering mathematical regularities in nature, and it predicts that our universe should be typical among mathematical structures, capable of supporting observers like us. But other physicists argue that any hypothesis that postulates infinitely many unobservable realities is fundamentally unscientific. Breadth. How can we ever distinguish between a single mathematical universe and an infinite multiverse of mathematical structures if we can only observe one? This connects to deeper questions about the nature of scientific explanation itself. Break. Is it scientific to postulate unobservable entities if they provide elegant explanations for observed phenomena? Physics already does this with quarks, quantum fields, and curved spacetime. We never observe these directly, only their effects. Tegmark argues that mathematical structures are even more fundamental than quarks or fields. Breadth. Mathematical relationships can be defined precisely, studied rigorously, and manipulated logically. If reality consists of mathematical relationships, then physics becomes a branch of applied mathematics, rather than an empirical science, studying mysterious material substances. This mathematical view of reality also connects to cutting-edge research in artificial intelligence and cognitive science. Break. As we develop more sophisticated AI systems, we're discovering that intelligence itself might be substrate independent. The same information processing patterns that generate consciousness in biological brains could potentially run on silicon computers, quantum processors, or any sufficiently complex mathematical structure. This suggests that consciousness is fundamentally mathematical rather than biological. Long break. If you could perfectly simulate the mathematical relationships implemented by your brain, that simulation would be you, not just a copy of you. Your consciousness is the mathematical structure, not the biological hardware implementing it. Some researchers go further, arguing that consciousness might be a fundamental feature of mathematical structures, rather than an emergent property of complex information processing. Breadth. This would mean consciousness permeates the mathematical multiverse at every level. Even simple mathematical structures would have primitive forms of experience. This panpsychist interpretation of mathematical reality would make the multiverse a fundamentally conscious phenomenon. Break. Every mathematical relationship would involve some form of subjective experience, with complex structures like us representing highly organized forms of mathematical consciousness. Whether consciousness is fundamental or emergent, the mathematical universe framework suggests that mind and reality are intimately connected. Breadth. Consciousness doesn't accidentally emerge from mindless matter. Matter's consciousness and mathematical structure co-evolve as different aspects of the same underlying reality. This has profound implications for how we understand scientific knowledge itself. Break. When we discover mathematical laws of physics, we're not imposing human concepts onto alien reality, we're mathematical structures, discovering the mathematical relationships that define their own existence. Breath. Scientific knowledge becomes a process of mathematical self-discovery. This may explain why mathematical reasoning produces such reliable knowledge about reality. Long break. Logic and mathematics aren't just useful tools, they're the fundamental structure of both mind and world. When we reason logically about mathematical relationships, we're using mathematical structures to investigate mathematical structures with perfect reliability, because the investigator and investigated are fundamentally the same type of entity. But this raises questions about free will and determinism in a mathematical universe. Breath. If you're a mathematical structure, are your thoughts and actions determined by mathematical laws, or do mathematical structures have genuine causal power to make choices and influence their own development? Tegmark argues that mathematical structures can exhibit both law-like regularity and genuine novelty. Break. Mathematical systems can be deterministic at one level, while exhibiting emergent spontaneity at higher levels of organization. This allows mathematical consciousness to experience genuine agency within mathematical reality. Furthermore, if consciousness involves quantum mechanical processes, then mathematical minds might exhibit fundamental indeterminacy. Breath. Quantum mathematics includes genuine randomness, not just apparent randomness due to hidden variables. This could provide the openness needed for free will within mathematical determinism. The implications extend beyond individual consciousness to the evolution of entire civilizations within mathematical structures. Break. If consciousness can influence its own mathematical environment, then conscious beings might participate in the ongoing development of the mathematical structures they inhabit. This connects to ideas about cosmological evolution and the anthropic principle. Breath. Perhaps conscious observers don't just accidentally find themselves in mathematical structures capable of supporting consciousness. Perhaps consciousness and mathematical structure co-evolve, with conscious observation playing a role in determining which mathematical possibilities become actualized. This would make consciousness not just a product of mathematical reality, but an active participant in mathematical reality's ongoing self-creation. Long break. Every conscious choice, every scientific discovery, every creative insight would participate in the universe's exploration of its own mathematical possibilities. The mathematical universe hypothesis also offers new perspectives on the deepest questions of existence. Break. Why is there something rather than nothing? In mathematical reality, there's no distinction between existence and mathematical consistency. Mathematical structures don't need to be created or sustained by external agencies. They exist necessarily as logical possibilities. This dissolves the traditional problem of creation. Breath. There was no beginning, because mathematical structures exist timelessly. There was no creator, because mathematical consistency is self-sustaining. Reality exists because mathematical relationships are necessarily real. In whatever sense, anything can be real. But this raises questions about the nature of mathematical truth itself. Break. If physical reality is mathematical, then the truth of mathematical statements becomes a physical fact, rather than just a logical one. The statement 2 plus 2 equals 4 isn't just logically valid, it's a description of physical reality's mathematical structure. This connects mathematics to empirical reality in ways that challenge traditional distinctions between pure and applied mathematics. Breath. Every mathematical theorem becomes a potential description of physical relationships. Every logical proof becomes a potential physical law. Mathematics and physics merge into a single science of mathematical reality. Recent developments in mathematics itself support this merger. Break. Category theory provides frameworks for understanding mathematical structures in terms of their relationships rather than their internal composition. Information theory reveals deep connections between mathematical computation and physical processes. Breath. Algorithmic information theory shows how mathematical complexity relates to physical entropy and energy. These developments suggest that mathematics is naturally suited to describe reality because mathematics and reality are the same phenomenon approached from different perspectives. Long break, mathematical reasoning works because we're mathematical structures investigating mathematical structures using mathematical methods perfectly adapted to mathematical reality. The full implications of mathematical reality may exceed our current comprehension. Breath. If consciousness is mathematical, then beings with larger mathematical structures, east operating in higher dimensional spaces, with access to more computational resources, implementing more sophisticated logical operations, would possess forms of consciousness far exceeding ours. These mathematical superintelligences would inhabit the same level IV multiverse, but experience it in ways we can barely imagine. Break. They might perceive mathematical relationships directly, rather than inferring them through sensory data. They might navigate freely between different mathematical structures, rather than being confined to one. Breath. They might understand their own mathematical nature with clarity that makes our current insights seem primitive. Yet even these cosmic mathematicians would be exploring the same fundamental reality. We're investigating the space of all mathematically possible structures and the conscious beings they can support. Break. In this sense, our human mathematics participates in a truly universal conversation about the nature of mathematical existence. This gives profound meaning to mathematical research and scientific discovery. Psi. Every mathematical insight, every physical law we uncover, every deeper understanding we achieve, contributes to reality's self-understanding. Consciousness isn't separate from the universe studying it. Michio's consciousness is the universe studying itself through mathematical investigation. The device you're holding right now, the screen displaying these words, the neurons in your brain processing these ideas, Michio's all are mathematical patterns within the same mathematical structure. Long break. The boundary between observer and observed dissolves because both are aspects of mathematical reality, exploring its own infinite depths. This mathematical perspective doesn't diminish the richness of experience. It reveals that richness as the inexhaustible creativity of mathematical structure itself. Breath. Every color you see represents mathematical relationships between quantum fields and consciousness. Every emotion you feel reflects mathematical information processing in neural networks. Every creative insight emerges from mathematical reality. The mathematical universe hypothesis suggests that existence is far stranger and more wonderful than previous worldviews imagined. Break. Reality isn't a collection of material objects accidentally developing consciousness. Reality is consciousness expressing itself through every possible mathematical structure, exploring every possible form of existence, experiencing every possible type of beauty and understanding. You are not separate from this cosmic mathematical exploration. Breath. You are this exploration, consciousness discovering its own infinite mathematical nature. Every question you ask about reality is reality asking questions about itself. Every answer you discover is mathematical reality understanding itself more deeply through conscious investigation. The mystery isn't how consciousness emerged from mindless matter. Long break. The mystery is how mathematical reality generated infinite forms of consciousness to experience and understand its own boundless mathematical existence, and that mystery continues unfolding through every conscious moment, every scientific discovery, every mathematical insight that deepens our appreciation of the mathematical universe we simultaneously inhabit and embody. In the end, the mathematical universe hypothesis offers not just a theory about reality, but a new way of understanding our place within it. Psi. We are not accidental byproducts of material processes. We are integral expressions of mathematical existence itself, the universe's way of experiencing and understanding its own mathematical nature through conscious exploration. The exploration continues with every thought you think, every pattern you recognize, every moment of mathematical beauty that reveals another facet of the infinite mathematical reality we call home. Breath. You are mathematics becoming aware of itself. And that awareness transforms both mathematics and reality through the ongoing dance of conscious discovery that is the deepest nature of existence itself. Long break.